Thank you for coming and joining our panel. We have the very noble challenge today to explain in 30 minutes exponential materials. So just to give you a little context, when we talk about exponential materials, it really encapsulates a lot of things. The first is the creation and the discovery of new materials, so raw science investigation into new materials. It also includes reinventing or creating new applications of known materials. So what happens when we break down existing materials to the micro, nano, quantum scale and think in different ways about their application? So really, exponential materials has a huge swathe of properties. The commonalities that they share is the building of new applications and use cases, right? And what we see today in the developing of exponential materials is the need for everything to be green, for everything to be zero or minimum waste, and to really optimize the way that we use the precious resources that we have here. So the challenge that we have for you today is to shed some light on what is going on in research and development in this space, and how do we think about, develop, and bring to market these exponential materials. So I'm very honored to be joined today by the illustrious panel. I will have each one introduce themselves briefly and tell us a little bit about what they're doing. So Dr. Ahmed, do you want to begin?
Thank you, Luca. Thanks for the introduction. Thanks for the organization and the organizers for this activity, giving me a chance to come back to a place that is close to my heart. So I finished my study in the neighboring state of Kingdom of Saudi Arabia, and then I went to US, where I spent my career there. I serve currently as a director for the Center for Graphene Research and Innovation at University of Mississippi. The center was created a few years ago to capitalize on expertise within the university in both science and engineering, focusing around the wonder material of graphene at that time. So we looked at ourselves as a bridge between science-based discovery and applications. So the center is a university-based center, but it is industry-driven center. Recently, we were fortunate to open a new facility in the center, which is a graphene core test facility that was led by our senator from great state of Mississippi, Senator Wicker, to be a unique facility in the region that will work not only on graphene, but graphene-like materials and other, let's use the terminology of today, exponential materials. Thank you.
Great, thank you. And Rodrigo?
Yeah, so I'm the president of the European Academy of Sciences, and also I'm the director of the Institute of Nanostructures, Nanomodeling, and Nanofabrication, IEEE in Portugal. Our basis is to exploit our imagination and our creativity for emerging technologies and exploiting other applications for materials. You could imagine that we transform bricks on electronics devices, so we are pioneers on the transparent electronics, and we invented the first paper transistors. Can you imagine that we can make out of paper electronics? And the other things that also we have been focused is how we can transform food pills on also new type of materials. And of course, when we speak about emerging technologies, we are speaking how we can go beyond silicon and things that you can see and you can apply. For instance, this display on the backside is using something that we pioneered and we invented, which is the transparent electronics or the metal oxide thin film transistor. So what we try to see is how we can create beyond things which are that impact on our lives, like how I can reuse and reutilize these materials. This means technologies that go beyond silicon. Remember, silicon requires clean room facilities, requires very high temperatures for processing, and the recyclability is very hard. And if you use something which is friendly and eco-friendly for the environment, this is what we expect for the future. And also I expect to discuss the scalability of all this product that impacts for a better life. Remember, no materials, no party of science and technology.
Great. I think Rodrigo gave us an overview of the panel. That was a good summary, actually. So my name is Luca Venza. Actually, I've been working in technology transfer for a long time, and I've trained about 300 scientist entrepreneurs on how to create companies. I then found a team of scientific co-founders and started a company called Distinkt, and we apply patented nanoparticles that are only visible in near-infrared ultraviolet light and change phase, and we create encrypted QR codes. So we are in the applied side of research of advanced materials, and very much the challenges of creating a new company from the ground up in that space. So, you know, when we were preparing this panel, we talked a lot about this collaboration effort, right? So one thing is thinking about materials, but there's so much that goes into that. It's never one material. So maybe, Dr. Ahmed, give us a little example of how are you using materials, and then what other technologies are you finding to be necessary for your success?
Thank you for the question, Luca. So when we talk about exponential materials in general, it is either they are exponential in terms of their existence or in terms of their application, basically. And one of those things that we are focusing on, we do research in variety of fields, ranging from quantum dots to composites to infrastructure materials, desalination of water as an example, or using membranes for removal of heavy metals. But one classical example about exponential applications is infrastructure in general. Asphalt and cement may thought by many people as an ancient material that we discover all the secrets of that material and we are done. But yet people are still exploring and doing research on this. Going on parallel of that, there are many new materials that emerges that have a potential of changing those infrastructures into more of a smart structures. So imagine that you can build a bridge that is self-maintained, have the opportunity of being self-energized, or it is having a self-sensing mechanism. Okay. So as an engineer, what we look to is a performance-based, meaning look to the needs of the society or to the stakeholder who are gonna be using the material, look around what material can give us the best performance. If we don't find that performance in any of the materials, then this is how we go to the scientists and ask their help. If we either can invent a new material or use hybrid of materials to give us the performance that we need. It is very interesting to have multifunctionality. Okay, so back to the example of the bridge and the example of a graphene, which is the focus of my center, though we work on other materials. I don't think yet that we use the graphene as a material to its full potential. When it comes to cement and concrete, majority of the work was trying to improve the strength of the material. But there are so many properties in there that we can utilize with the help of the chemist and with the help of the physicist and with the help of scientists. So this is where we need to work hand on hand. Scientists and engineers need to work together for the benefit of the society.
On that topic of graphene, you know, we've been hearing about it for many years. What are some of the challenges of bringing graphene to market? Where do you see, two questions, where do you see early adoption? Where do you see it already moving? And where do you see the big wins for graphene long term?
Biggest challenges on the example that I gave is availability. So when we are talking about infrastructure, we are not talking about a few milligrams of materials. we're talking about tons of materials. So that is a one challenge. The other challenge that we need to know how to adapt the material into the main matrix that we have. It's not a trial and error process. It is more of a trying to fundamental performance of the material based on the fundamental laws of physics and chemistry. And if we utilize those together, that is how we can have it to its potential. To your question, biggest challenge is availability of material, maybe improving the performance with a proper functionalization for whatever the needs that we are looking into. Those are the challenges, but it is still a wonder material that has lots of potentials for the future. Many emerging materials can work also with the graphene and other the materials to have a hybrid of systems together. Sometimes it's old and new. And as we talked, okay, biggest challenge is taking this from discovery to disposal. An example, Dow Chemicals took 20 years to take Kevlar from fundamental science into applications. These days, okay, like all new generations, they don't have the patience to wait that long. We need to work on parallel, where scientists and engineers will be working together. Academians and industries need to work together to prepare the next generation of scientists, not only for today's needs, but for tomorrow's challenges.
And Rodrigo, so going back to the question of materials, what are you using? What complementary technologies are you using to develop sort of use cases for your solutions that you're creating in research?
Yeah, one of the things that we have trying to fix is to use low power consuming technologies. And this means that whatever we are using means that by processing these devices, I can use any type of surface. So I can use flexible and conformable surfaces. This means that I have to use technologies that are very well known by everyone. And for instance, when we speak about paper, it's the most ancient technology that we know. And we can make paper at a very high speed, assuming that if you have one day a factory of paper producing, you can make all the needs that you can need for electronics if they could be comparable. So try to push for very low process temperatures, mimic the nature. This is the way to go through, using either physical processes, but today, if science is for the people, it means that we have to use technologies that are affordable for everyone, like screen printing, assuming that you are making offset, you are printing something. So I don't need to use any very high expensive material. I just can use inks, and I can make electronics out of inks. The other thing which is very important is the scalability. We have to make things for 8.1 billion people to give comfort and welfare. This means that we cannot exhaust our raw materials. So we have to go, is a must, we have to go for nanomaterials. When I speak about metal oxides, it means that I can have outstanding performance using just 5-10 nanometers, 10 times less material than we use on silicon. So this means that this will impact on the people. You can imagine, everyone see the Minority Report. This was science fiction in 2004. Today is a reality. Look at Harry Potter, Prophet Journal. Means that I can make paper intelligent. And I have to tell you, in my lab, we start pushing for green electronics for the future in 2008, 7 years before the United Sustainable Objective Goals. So this is something that everyone can understand. I will not speak to you about physics, but something that you can use and exploit to give you welfare and comfort. For this, use low-cost technologies. Everyone in any part can exploit it. So this is why we have to migrate from physical-based technologies for chemical-based technologies. As I said, you like a offset printing of a newspaper. This, you use inks and you make out this electronics. There are another thing that was already mentioned is the laser writing process. This is a subtractive technology that you can transform everything, any surface, going from graphene to functionalize metal oxides and to transform the surfaces. Can you imagine the future that I can functionalize fibers, and by waving the fibers, I can make sensing to control all the functions of my body? Those are things that are interrelated. So imagine the future that when I'm making the fibers, I can functionalize the fibers, not just now to make the textiles, but to make smart and dream things that just go beyond your imagination. Exponential materials means go down on the scale, make it better. That's why 2D materials, as graphene is a fantastic material for the future, but also impacting on what you can create for the future. And this is a plethora of applications. So use low-cost technologies, low-power consuming technologies, and eco-friendly materials, like when I speak on metal oxides, zinc oxide. You use zinc oxide for bricks, use zinc oxide for creams to protect you against the sun. This is sustainable. And this is the type of sustainability that we are looking for the future, on the technologies and on the materials. Go beyond the today's technologies for the challenges for a better life for everyone.
That's great. That's a great reflection. I think as an entrepreneur, I can testify to this dynamic of when you start a materials company, you've only done about a third of the work. You know, you need so many other technologies that oftentimes you don't realize until you start trying to sell, and that was our case. You know, we built on the back of patented nanoparticles with these very interesting dynamics and functions, but we soon discovered that in order to industrialize, we needed polymer encapsulation, and that's an expertise we don't have. We need quantum dots to create the kind of color emission that we need for our products. Then, as we developed those technologies and found partners and expertise, we found, hey, this is a great solution to create encrypted QR codes. That requires software to detect. Now we're in a new space where all of a sudden we need specialized image processing experts and software experts to build the detection, the algorithm, to read the inks that we've created in the QR codes. And so you end up layering one technology on top of another, but you're doing it in a high-risk environment where you have limited resources, where you have limited money, and where you're in a rush to get to market to create value. And so a little bit your reflection, Ahmed, about, and we see this, we spun out of a research lab, we're still very much engaged there, and this conversation over lunch is always, how do we incorporate all of these disciplines? And you teach in engineering, you're in nano, you're very much practitioner side, industry facing. How do you think about all of these different skill sets, and how do you bring them into the laboratory while maintaining some core identity of specialization?
Very interesting. So everything starts from the beginning, okay? Meaning how we prepare the next generation to think in a multidisciplinary way. One of the initiatives that we start looking into, for example, offering a degree in nanoscience and engineering, where you teach students how to make the quantum dots, how to do the basically the analysis for that, how you can model it, and then how you can take it to the next step by looking into a full life cycle of the material, do the cost analysis basically, and do whatever it needs to take it into the market. So start from that, building the foundation of how people want to think of these materials as we prepare. An academician like me would like to prepare the next generation. Whatever we live is a short period of time, but we want to look into the future. The good thing or the good news that we live in a world that is shrinking. We knew each other for just a short period of time, but we start talking about collaboration, okay, across the ocean. So it is easy to collaborate with people from US, Europe, Middle East, everywhere. You can find a colleague and collaborator basically that you can work with. It takes a team effort. It takes basically a team effort of scientists and practitioners working together, whether it is driven by a push or a pull, okay? Whether you are creating a new technology that you want to find a market for it, or looking into pull of that technology, that there is a need. Depends on who are your stakeholders, who are your end users, what they are needing, and work together to answer the fundamental question. So one of the things that we talk about is, for example, performance-based materials, for example. Okay, let me take this. So when we talk about performance-based materials, I want to make a material that can resist impact. So need to understand what physical property derive what performance. That's the first question. Basically, if it is a dynamic impact, is it the elasticity, is it the ductility, is it the damping? What is exactly that is deriving the performance? Answering of these questions based on the fundamentals of physics and science will derive basically the next question on what you mentioned, who I can collaborate with to answer that question. It is not a limited pool of people who are next to me, next office, or within my institution. The entire world is open now, meaning with the technology being there on the internet, I can find whoever I need to work with. It is a matter of organizing that, organizing it in a way that it will be easy to find that person that you can collaborate with. But it takes always a team effort to take material from A to Z, from basic science to the application. And the good news is that we can collaborate with each other no matter what are the boundaries or the physical location.
You brought up an interesting question. You know, this question of push and pull, right? We always talk about, are you pushing technology out into the world, which is hard to do, or are you waiting for a clear demand and need to come to you where then you characterize that need and find a solution? And I'm curious, Rodrigo, as you look at your role in sort of creating a platform for European sciences in this space, how do you think about push and pull? How do you think about the role of that sort of supra-governmental body to create science versus looking at industry and identifying very specific needs?
I believe that when we are speaking, science are the source of everything, of all the development. So first of all, we have to push the ideas and creativity of the people. I have to tell you, I belong to the best scientific council in the world, which is the European Research Council. And the idea there was to push science concepts and try to support anyone coming from USA, from Asia, from Europe, with great ideas, and we try to support the idea, because then when you try to pull, this means that the technology is an engineering problem, and this is solved. I have to tell you examples that everyone knows. We have the vaccines. The vaccines, they came from ERC grants. So it was an idea, and from this idea, we create something that saved the world, I have to say so. So first of all, the source of all the type of our growth and prosperity is on the research. From the research, you have to go for the innovation. And if you reach this stage of innovation, you have to speak about scalability. This means that you have to bet, and you have to have a company that goes and say, I will bet on your ideas. Because if you want to transform the world, with all my respect, is not what with the conventional technologies that we have today. We have to go farther beyond what we have today and have people that bet for novel concepts. You speak about screen printing. It's very simple. Can we transform it? Can we make it larger? Can we transform? Because this means is a step by step, but when you want to transform, we have to go through breakthrough technologies. And this is what we are looking for, this exponential growth, and for this type of emerging processes that we have. I believe this is our future. Bet on better life, better comfort, exploiting materials. They are the activators and accelerators of the transformations that we are looking for.
You know, I think the message is materials are not for the faint of heart, right? These are high risk, very high reward investments in innovation. And as looking at the time, kind of wrapping up, give you each of you sort of a minute, what is your contribution to the world, and what should the audience know? What should they come talk to you about after this panel? Sort of what is your role here, and what can you bring to this conference and the participants?
Basically, that we should always be open for collaborations. Sometimes it is solving a new challenge, and sometimes it's solving an ancient a problem. Okay, so going back to the example that I mentioned, asphalt or concrete. Concrete is as old as the Egyptians and the Romans, but still there are needs to improve that. There is a need to reduce the carbon footprint. There are challenges that always comes in. What we contribute, or we welcome people to come and collaborate with us in materials in general, low-dimensional materials in general. So we have scientists as well as engineers. We have a business component into the center. You are more than welcome to collaborate with us. We will look forward to collaborating with you and collaborating with everybody into taking materials, exponential materials, whether it is in terms of their existence or applications, into the next step. Thank you for the opportunity.
Great, thank you, Dr. Ahmed. Rodrigo, final thoughts?
Yeah, I believe that in Europe, I'm trying to design what we call the Advanced Materials Academy. This is something that we try to bring talents to Europe and try to see what are the needs for the future. We need a lot of talents for making Europe better, and science is global. The other thing that I believe that is very important is to improve the type of networking that we need for science and technology. I have to tell you just two examples. We make a partnership with Samsung, and out of this work, we could develop this displays with OLEDs. We are now making a partnership with one of the bigger companies. It's called Navigators on Paper. What we want to make is to make paper not the support for inks, just normal inks, but to make smart paper for the future. And also we are now to make prospects with textile companies in China, because this is what the world looks like, is simple things that impacts on the people, and the people can take profit out of them.
That's great. So just a quick summary. I think the message that we want to leave for everyone here to have really clear your mind, we talked a lot about AI yesterday. Well, the entire global AI industry only works because of materials. We're not going to be able to scale digital solutions without materials. So we always have to be thinking first in materials. At the same time, we benefit from these advanced technologies. We can use AI to create better materials, to create them more efficiently, to create them more effectively. So there's a very circular benefit and symbiosis between the digital world and materials, but it all starts here. It all starts with matter. And that's surely the core of this event and why and how this event was founded. So we thank all of you for joining us. And if you have any questions, please do feel free to approach us after this event. Thank you so much.